Hello, my name is Teona. I'm going to talk in general more about stack and queue for BFS and DFS search. So let's start with stack. In stack, the stored data, it's in order, last in and first out. When we add an entity, it's pushed onto the stack on the top of the previous entry. When we want to remove one, we pop the top entity out. So in this example here, we can see the last entity, entered entity, it's 2. So we're just gonna pop 2 out. We also can see that there is a pointer called top that is pointing on the last element in the list. In stack, the first entry added is the last element in the list. So for example, first entry added, it's 5, and 5 is the last element in the list. From the other picture, we can see that there is an empty one, and then we add data 1, and then we add data 2, then we add data 3. When we want to, let's say, remove data 1, first we have to start removing data 3, then data 2, and then in the end we remove data 1. Queue. In queue, the stored data, it goes in order, first in and first out. Data ended in the front, it's called in queue. And when an entity is in-queued, it is added behind the previous entity. When the data is removed, we call it dequeued. So when an entry is dequeued, it is removed from the front. In queue, the first entry added will be the first entry removed. We also have pointers here. So here is the front pointer. It points to the first element, which is 1, and there is rare, which is in the end, and in this example is number 10. Let's talk more about BFS search. So BFS search uses queue data structure to find the shortest path. It proceeds level by level. It is also used to find the shortest path with unit weight edges from a node to another one. So let's see the example here. In BFS search, there is the root, and in this example, the root is A, and there are nodes B, C, D, E, F. So from root A, first we go to the shortest path, which is on the left side, which is B. Then we go back to the top, and we use the next shortest path, and from C and D, in this situation, is C. Then we go back to root A, and then we use the last one, the last node, which is D. Then we go to C, to node C, and then from C, we choose the shorter one on the left side, which is E, and then the last node will be F. Let's look at DFS search. DFS search uses stack data structure to find the longest path. We retrieve it from the roof to the furthest node as much as possible. So it will be the same as last in, first out. So the same as stack. It is more efficient, more memory efficient because it stores number of nodes at max the height of the DFS tree. First follows apart from the starting to the ending node vertex. Then another path from start to end, and so on until all the nodes are visited. So let's see in the example here. Again, we have root A, and then we have nodes B, C, D, E, F. So here we use the longer path. So from root A, we're gonna take D, which is on the right side. Then we're gonna use F because it's connected to D. Then we're gonna go back to the top. The next longest path from B and C, in this case, we're gonna choose C. Then from C, we're gonna choose E, and then we're gonna go back to the root again, which is A, and then we're gonna choose the last node, which is B.